If you listen to mainstream tech coverage, running your own local AI requires dropping thousands of dollars on a massive desktop tower with a high-end dedicated graphics card. But that narrative ignores the reality of modern software. You can actually run highly capable AI models completely offline using an aging 2017 laptop with a dual-core processor. The central technical dilemma is memory. You are trying to squeeze a neural network containing billions of weights into a rigid 8 GB pool of older DDR3 RAM. This table breaks down the shift. Traditional AI models demand 16 GB of dedicated video memory or more, but the industry is shifting to small language models, which are specifically trained to run on standard processors and squeeze into tight 8 GB memory limits. Now, to be clear about the trade-offs, an older machine is not going to give you omnipotent artificial intelligence, and it will not handle seamless multitasking between heavy applications. The value here is securing a highly capable, specialized assistant that runs entirely on your local machine, keeping prompts completely private and off the internet. To pull this off, you have to trade hardware brute force for extreme software discipline. Every megabyte of background data has to be managed. When you apply that level of optimization, you take a computer destined for the e-waste bin and turn it into a zero-cost private AI workstation. Before you even think about downloading an AI model, you have to look at the foundation, your operating system. This chart shows an 8 GB RAM limit. Standard Windows 11 easily consumes 5 GB idling. Installing Windows 11 IoT Enterprise LTSC cuts that to 1.5 GB, opening up 6 GB of free memory. Hitting that red ceiling triggers paging, dropping speeds to a crawl. To avoid that paging trap, you have to follow a strict budget. Your AI model file and its active working memory combined must stay under 3.5 GB. Choosing that lean operating system does mean sacrificing the Microsoft Store and other mainstream consumer features, and it requires some technical tweaking to set up. But ruthlessly defending that 5 to 6 GB of free RAM is the single, non-negotiable step that allows your laptop to load a model in the first place. Once the memory is clear, the next hurdle is getting a dual-core laptop processor from 2017 to actually generate words at a readable speed. AI inference at its lowest level is essentially a massive, continuous sequence of matrix multiplications to predict the next word. Look at this diagram comparing two types of processing. Standard scalar processing handles one number at a time. The bottom row shows the AVX2 instruction set, which packs up to 32 integers into a single register and processes them all in a single clock cycle. The software engine running under the hood, a framework called llama.cpp, is written specifically to detect those AVX2 capabilities on your processor and route the mathematical workload straight through those wide registers. We use a technique called quantization to compress the neural network's weights down into tiny 4-bit or 8-bit integers, which allows them to perfectly fit into those parallel AVX2 batches. Pushing these intense math calculations across all available threads means your CPU is working at absolute maximum capacity. Expect your processor usage to pin at 100%, your cooling fans to get incredibly loud, and your battery to drain fast. You will want to stay plugged into the wall. That specific AVX2 optimization bridges the gap between everyday laptop hardware and dedicated graphics cards, making local processing viable. Moving from text generation to the massively heavier computational burden of image generation. Standard Stable Diffusion calculates hundreds of thousands of pixels simultaneously over dozens of steps. Trying that on 8 GB of RAM and 2 cores will either freeze your system or take half an hour per image. Instead, you should use highly distilled models like SDXL Turbo, which can resolve high-quality images like this one in just a single mathematical step. As you can see in our RAM budget chart, you cannot run both at once. You have to completely clear out your text model from active memory before loading up your image model. You also have to cap your generations at a strict 512 by 512 resolution. Pushing it higher quadruples the pixel math and guarantees an immediate system crash. Creating images locally on a legacy device works beautifully, provided you manually swap your models and stick to those rigid resolution limits. To stay within all of these hardware constraints, you need to be highly selective about which small language models you download to your system. If your main focus is everyday tasks, general knowledge, or creative writing, the 4-bit quantized version of Gemma 3 4B is fast and easily fits the memory budget. This flowchart helps narrow it down. If you need structured reasoning, code completion, or logic, follow the path to Microsoft's 5.4 Mini, which behaves like a much larger model while taking up less than 3 gigabytes. Firm warning tone. You have to steer completely clear of any 7 billion or 8 billion parameter models. Even highly compressed, the second you type a long prompt into one of those, it will overflow your context memory and freeze your computer. Matching the exact model size to your specific daily task keeps the dual-core processor from buckling under impossible workloads. Ultimately, you are making a deliberate trade-off. You are leaving behind the massive encyclopedic knowledge of server-grade AI in exchange for absolute privacy and zero subscription costs. This precise configuration works best for developers testing code offline or anyone on a strict budget who wants to explore AI infrastructure. If you are a beginner, it helps to keep your expectations grounded. This legacy setup cannot run chat, vision, and audio tasks simultaneously. Everything has to be sequenced one step at a time. If your daily workflow requires loading large models, multitasking between tools, or generating high-resolution images, you will need to invest in modern, GPU-heavy hardware. But if you are willing to apply strict software discipline and optimize every gigabyte, your aging hardware still has plenty of life left in the modern era.